The last video demonstrated that if we want to be good scientists and report numbers that have meaning, we need to take account of significant figures. We need to be able to determine the overall significance or the overall precision of a number. So in this video, we'll learn how to do that by learning the rules for the significance of digits within a number. Now, to a first approximation, the total significance or the total precision of a number is just its number of significant digits. So once we know how to assign significance or not to a digit, we'll be able to determine the total significance of a number. The key question then is, how do we determine whether a particular digit is significant or not? And when I say significant, you can almost think to yourself, significant to the value of the number or not. Is the digit just a placeholder? Is it just showing us really which power of 10 we need to multiply the number by to generate the actual quantity? Or is it actually important to the value? In other words, if we changed that number or wrote it in a different way, would that actually change the value of the number? That's kind of what's implied by this word, significant. So there are four big rules to keep in mind when we're determining the significance of a digit within a number. The first is that all non-zero digits are significant. And this makes sense. Non-zero digits are obviously essential to the value of a number. In the number 9,342, if we changed any of those digits, that would change the value of the number. So all four of those are significant. This number has four significant digits. The second rule is that zeros between significant digits are themselves significant. So in this number, 48,009, the two zeros that fall between the 8 and the 9 are indeed significant. The way to think about this is that significant digits need to show up next to one another. So significant digits within a number are a contiguous string of digits. That means if we have two significant digits on either side of a string of zeros, the zeros in the middle must be significant as well, because the entire block of numbers, in this case all the way from the 4 to the 8 through the zeros and to the 9, is significant. This number has 5 significant digits. Rule number 3 is that the zeros on the far right after a decimal point are significant. This is probably the most arbitrary of the rules and the one that's a little bit difficult to explain. For example, in the number 5.347000, the 3 digits on the far right are considered significant. You might be saying to yourself at this point, couldn't we just lose those zeros and get exactly the same value out? And the answer is not exactly. What you're assuming is that if we lost those zeros, we would be able to assume that after the 7, there is an infinite number of zeros that follows the 7. But when it comes to scientific measurements, having no numbers after the 7 means we don't really know what the digits after the 7 are. They could be anything. So adding the extra zeros tells us that yes, indeed, those numbers following the 7 are zeros. And they add precision because we're adding places after the decimal point. So 5.347000 is indeed more precise than just 5.347. And so all 3 zeros in this case are considered significant. Finally, zeros between a significant digit and a decimal point are themselves considered significant. So for example, 460.0. In this case, the 0 before the decimal point, the one with the red arrow underneath it, is considered significant. It falls between a decimal point and the 6. Another way to think about this is that it falls between the 0 after the decimal, which is a significant digit, and the 6, which is of course significant. So that 0 in the middle is significant. You'll sometimes see numbers written without any numbers after the decimal, something like 460 dot. And the 0 in that case is also significant. The purpose of the decimal place is to illustrate that that last 0 is indeed significant. So you can almost in your mind think of the decimal point as a significant digit in and of itself. It of course doesn't count to the total number of significant figures in a given number. The one that you see here, the 460.0, has 4 significant figures, but it's sort of a marker of significance. Zeros that fall between a decimal point and some other significant figure are indeed themselves significant.